Along with electric fields, the region surrounding any moving electric charge also contains a magnetic field. Let's take a look at what magnetic fields actually look like. This is an example of Earth's magnetic fields. Like gravitational fields and electric fields, magnetic fields are not visible. Let's look at two different scenarios. Generally speaking, opposite poles attract to each other. As you can see, the north and south poles are attracting each other, thus creating dome-like field lines. Rather, between similarly charged poles, the north poles are repelling each other, thus creating reverse field lines with each other. The strength of magnetic fields is directly proportional to the charges in a region. With this demonstration, the opacity of the small field lines represent the strength of magnetic fields. When I decrease the strength of the charges, the field lines decrease in opacity. Rather, as I increase the strength of the charges, the field lines increase in opacity. Here are a couple of magnetic force traits which make them radically different from electric forces. The velocity vector and the magnetic field make an angle between themselves, and the magnetic force is proportional to the sine of theta. The magnetic force acts in a direction perpendicular to both velocity and magnetic field, which are represented by these equations. To determine the direction of the magnetic force, we utilize the right-hand rule. Also, here are the symbols for representing the direction of magnetic fields. Here are some magnetic field applications. All of these different experiments consist of the same idea that magnetic fields direct particles, while electric fields accelerate particles. Let's take a closer look at a velocity selector. We can tweak a magnetic field so that the magnetic field works perpendicularly with the charge, thus forcing it to go in a straight line. So we need the magnetic field to go into the paper. For an electron to make it through the uniform magnetic field and uniform electric field, it must consist of velocity E over B. There are many different applications of magnetic fields. We can look at moving charges with the Biot-Savart equation, or we can look at the magnetic force in a wire of current. All in all, these are the basics of magnetic fields.